This video is on the anterior pituitary gland. If we take a look at this diagram here, you can see the hypothalamus and the anterior pituitary gland. You can see these structures here are neurons that are located within the hypothalamus, and then we have a blood network shown here. These neurons secrete their hormones into a capillary bed, which feeds into portal veins, which then connects with a second capillary network, which supplies the endocrine cells of the anterior pituitary gland. These hypothalamic neurons secrete trophic neurohormones. Trophic hormones are hormones that control secretion of other hormones. The hormones secreted from these hypothalamic neurons then travel in the circulation a very short distance down to the anterior pituitary gland, where they then affect the secretion of these endocrine cells in the anterior pituitary gland. We'll come back to the hypothalamic hormones. What's shown on this slide are the hormones secreted by the anterior pituitary gland. So prolactin, growth hormone, thyroid stimulating hormone, adrenocorticotropic hormone, and the gonadotrophins, luteinizing hormone and follicle stimulating hormone. Overall, the anterior pituitary gland hormones control growth, metabolism, and reproduction. So together they target many tissues and have quite broad effects. Prolactin is important for controlling milk production in the mammary glands. Growth hormone targets many tissues around the body and has important effects on growth and also metabolism. Thyroid stimulating hormone targets the thyroid gland and controls synthesis and secretion of thyroid hormone. ACTH targets the adrenal cortex and controls synthesis of cortisol. The gonadotrophins, luteinizing hormone and follicle stimulating hormone, control the function of the ovaries and the testes, so therefore are important in reproduction. This is an overview slide of information we've already covered to date. Remember that the hypothalamic neurons secrete hormones into the vascular system that supplies the anterior pituitary gland. In turn, these hormones affect the secretion of anterior pituitary hormones, all shown here and covered on the previous slide. A little more now on the hormones that are secreted by the hypothalamic neurons and control the anterior pituitary. The hypothalamus secretes what we call releasing and inhibiting hormones, and these are the trophic hormones that I mentioned a short while ago. These releasing and inhibiting hormones influence secretion of anterior pituitary hormones. And it's probably not surprising, based on the terms, that releasing hormones stimulate release of anterior pituitary hormones and inhibiting hormones inhibit release of anterior pituitary hormones. If we have a look at the table on the bottom of the slide, in this column are listed the anterior pituitary hormones. You'll see in some cases there's more than one name for a particular anterior pituitary hormone. The red star is next to the term that's most used. So it's recommended that you use this term in this topic. You don't need to memorise both terms, just the one with the star next to it. In the second column here, we have the hypothalamic releasing hormone. So these hormones will stimulate release of the anterior pituitary hormone. So thyrotropin releasing hormone will stimulate release of thyroid stimulating hormone. Corticotropin releasing hormone stimulates release of adrenocorticotropic hormone, often referred to as ACTH for short. Growth hormone releasing hormone stimulates the release of growth hormone from the anterior pituitary. And gonadotropin releasing hormone stimulates both FSH and LH from the anterior pituitary. In the third column, we have hypothalamic inhibiting hormones. So you can see there's fewer of the inhibiting hormones than there are of the releasing hormones. Dopamine is an inhibiting hormone for prolactin, and also note that there's no releasing hormone for prolactin, simply controlled by dopamine as an inhibiting hormone. We also have somatostatin, also called growth hormone inhibiting hormone, and that inhibits the release of growth hormone. So you can see from this list there's only one anterior pituitary hormone, that's growth hormone, that has both a releasing and inhibiting hormone. In summary, the releasing hormones secreted from the hypothalamic neurons stimulate release of anterior pituitary hormones, and the inhibiting hormones do the opposite and inhibit anterior pituitary hormone release. This slide is a summary slide. We have covered all this information in the previous slides, but it's a great way to see all of these processes together in one view. What's shown up the top are the hypothalamic hormones. Then the anterior pituitary hormones, the endocrine targets of the anterior pituitary hormones and the hormones they secrete, and then non-endocrine targets. So back to the top of the slide, remember that the hypothalamic hormones are either releasing hormones or an inhibiting hormone. And we refer to these as trophic hormones because they control the secretion of other hormones. Remember that these hypothalamic hormones are neurohormones secreted from hypothalamic neurons into this vascular network. In the dotted line, you'll see inhibiting hormones, dopamine and somatostatin, and in the solid black arrows are the releasing hormones. Then in turn, these are the hormones that the anterior pituitary secretes that are under control by the releasing and inhibiting hormones. What's shown here are the endocrine targets and the hormones they secrete. So thyroid stimulating hormone targets the thyroid gland to release thyroid hormones. These target many tissues in the body. ACTH targets the adrenal cortex, which secretes cortisol and also targets many tissues in the body. Growth hormone targets the liver to secrete insulin-like growth factors, which in turn targets many tissues. Growth hormone itself also targets many tissues. FSH and LH targets the endocrine cells of the gonads, which in turn produce testosterone and estrogen and progesterone. Both androgens, or testosterone and estrogen and progesterone, target many tissues, and also both androgens and estrogen and progesterone target the germ cells of the gonads and are important in reproduction. So as I mentioned, this is a summary slide that presents all of the information in one view that's been covered in this topic. Let's take a look at the feedback loops in the hypothalamic anterior pituitary pathway. We've looked at simple endocrine reflexes. Now we'll take a look at complex endocrine reflexes. And in this case, we have three integrating centres shown here, here and here. So the hypothalamus, the anterior pituitary and the endocrine gland are all integrating centres. So we start off with a stimulus that targets the hypothalamus. It then releases a trophic hormone, which then travels in the circulation to the anterior pituitary. The anterior pituitary then also releases a tropic hormone which targets an endocrine gland. The endocrine gland then secretes a hormone which has a target tissue with a response. In the case of more complex endocrine reflexes like the one shown here, the hormones themselves are the negative feedback signal. And this is because no single response can be easily monitored. So what we'll look at on this slide are the short loop negative feedback and the long loop negative feedback. The short loop negative feedback is when a pituitary hormone feeds back to decrease hormone secretion by the hypothalamus. So this is shown here with this dotted line. With the long loop negative feedback, it's important to note that this is the dominant form of feedback, where the hormone secreted by the peripheral endocrine gland, shown here, suppresses secretion of its anterior pituitary and hypothalamic hormones.